Hey everybody, we're back with another lesson on definite integral versus area. I really want to drive this point home so we're sure about the difference. So we're just going to work this first example here, number 1, and we're going to take number 1 through these 3 steps. So here's what it says. For problems 1 and 2, complete the following. Graph the function over the given interval. Okay, so let's do that first. We've got y equals x squared minus 6x plus 8 from 0 to 3. So let's start plugging in values. If x is 0, we're going to have y equals 8. Uh-oh, I don't think I went high enough here. Okay, 0. 1, 2, 3, 4, 5, 6, 7. I'm going to go here, 8. Sorry, I went off the graph there. Okay, if x is 1, we'd have 1 minus 6, which is negative 5, plus 8 is 3, so 1, 3. 1, 2, 3. Boy, this is really, actually 1, 3 is more here. Geez, it's hard to see. And then x equals 2, we would have 2 squared is 4, minus 12 is negative 8, plus 8 is 0, so 2, 0. And then finally, if I plug 3 in, I'm going to get 9 minus 18, which is negative 9, plus 8 is negative 1, so 3, negative 1. So this graph is quadratic, as we know. It's going to come down through here and then come underneath the x-axis just ever so slightly. Okay, first bullet, check. Next bullet, find the definite integral. Okay, definite integral is simple. We quite literally just sweep through with no regard to anything. The definite integral is going to take care of everything. I'm just going to set up the definite integral from 0 to 3 all the way through of my function x squared minus 6x plus 8 dx. I'm going to anti-differentiate that, so that's going to give me 1/3 x to the 3rd minus 3x squared plus 8x, and I'm going to bracket that from 0 to 3. And if you missed the lesson a little earlier in the week, we normally would add a plus c here, but when your integral is definite, and you're definitely going to put the top bound in and then subtract the bottom bound in, you know those c's are always going to drop out. So when you're doing a definite integral, you don't need to have the c. You can take it, but you don't have to. All right, now let's plug our 3 in. So I'm going to have 1/3 times 3 to the 3rd minus 3 times 3 squared plus 8 times 3 minus, now I put that 0 in, 1/3 times 0 to the 3rd minus 3 times 0 squared plus 8 times 0. And this back end, with all those zeros, that's going to disappear, so I can really just focus on the front here. So I've got 3 to the 3rd is 27, divided by 3 is 9, minus 3 squared is 9 times 3 is 27, plus 24. And so my final answer, 9 minus 27, is negative 18, plus 24 is going to give me 6. Now let's talk about what that 6 represents. If 6 is the definite integral from 0 to 3, then what this entire process just did is it took this area right here between the function and the x-axis from 0 to 2. It took that area and automatically subtracted this area. That's what it does. Fundamental theorem will automatically do that for you. Now, with that being said, we're going to go on to bullet number 3. Find the total area of the region over the given interval. Well, my first thought is the total area, which is my 3rd bullet, is definitely going to be more than 6. Because if the definite integral took the top minus the bottom, then the total area, which would be the top plus the bottom, is going to be more than 6 because I'm adding, not subtracting. But to manually figure this out, it takes a little more thought. So what you're going to have to do for total area is first, you're going to have to break it from 0 to 2. You're going to have to take that which is up and find that. So let's go ahead and just evaluate the definite integral from 0 to 2. Okay, A lot of this is going to be the same because you already know your antiderivative is 1/3 x to the third minus 3x squared plus 8x. But now we're just going from 0 to 2. Okay, we plug in our 2. We get 1/3 times 2 to the third minus 3 times 2 to the second plus 8 times 2 minus, put your 0 in, 1/3, 0 to the third minus 3 times 0 squared plus 8 times 0. Love when I'm working with 0 because this is going to go to 0. We can focus on the front. What do we have here? We've got 2 to the third, which is 8. 8 times 1/3 is 8/3 minus 4 times 3 is 12 plus 8 times 2 is 16. So then, let's see, the negative 12 and the positive 16 would make 4. So 8/3 plus 4. And if I get a common denominator, I would have 8/3 plus 12/3, which is going to give me 20/3. Or 6 2/3, sorry, 6 2/3. Okay? Now, I shouldn't have circled that. Don't circle that. That's not the final answer. I only circle final answers. That's just my area from 0 to 2. So up here in blue, I now know I have an area of 6 2/3. But I still have to figure out how much I have from 2 to 3. So that'll be my next integral. I think I'll just come over here and work since I have some space here. So I'm going to take the definite integral from 2 to 3 of the same function, x squared minus 6x plus 8 dx. Once again, the antiderivative is 1/3 x to the third minus 3x squared plus 8x, this time going from 2 to 3. So I'll have some extra calculations since I'm not dealing with a 0. Okay, let's put that 3 in. 1/3 times 3 to the third minus 3 times 3 squared plus 8 times 3 minus, put the 2 in, 1/3 times 2 to the third minus 3 times 2 squared plus 8 times 2. Very tedious this is. Okay, so in the front I have 1/3 times 27 is 9 minus 3 squared times 3 is 27 and then plus 24 minus, here I have my 8/3 minus 12 plus 16. Some of these calculations are recognizable from earlier on, but I'm pretty precise about these things. I like to write them out. So now I've got, in the front quantity, I've got my 9 minus my 27, which is my negative 18, plus 24, we know is 6, minus, again, here's that 8/3 plus 4, which I did just do right here. 8/3 plus 4, I got 20/3. So I do feel pretty comfortable maybe just bringing this 20/3 in here, which is 6 2/3. So maybe I can just put that in there since I'm running out of room. So now I have 6 minus 6 2/3, which is just going to give me an answer of negative 2/3. Now let's talk about what that means. That means the area underneath here is just 2/3. Now the negative, of course, tells me where it is. This tells me that yes, it's under. But total area doesn't really care about that. Total area just wants the absolute value of everything and then to add it together. So if I take 6 2/3, this is going to be my final answer now. So if I take 6 2/3, which is 20/3, plus 2/3, this is my total area, that's going to give me 22/3, or 7 1/3 final answer. And what's interesting is you can go back to the definite integral here and see how that's working, because if you take 6 2/3 minus 2/3, you get 6. So the definite integral did exactly what I said it would. Total area, you have to kind of manually go in and figure it out. Okay, hope that helps. Again, just trying to hone in on the difference between definite integral versus area.